Hello students, now we will see the next point in the unit 1, complexity of the algorithms. So the first point we will see that how we can analyze the algorithms. So we have understood right now for one problem there are the different approaches. So for every approach we have the different algorithm. So let's consider one problem, finding the GCD among the two numbers m and n. So for this is the first algorithm where what we are doing is we are finding the factors of the first number m and we will store that into one list or the array. So we will finding out the factors of the second number and we will store that into the second array. After that, in the third step, we will finding out the common factors and we will multiply them and we will return the result as the output, which is a greatest common divisor. So in this way, this is the one approach to find the GCD among the two numbers. So the second approach is Euclid method, where what we are doing is we are using the two number m and n, and we will see that m and n. If I will say that my m and the m, if the, for example, suppose it is 15 and the phi is m. So here we will see that whether my m is completely divides n. If the remainder is 0, then it will not going to enter into the while loop and it will return the m directly. So here greatest common divisor is 5, it will return. For example, if we have the 48 and we have what the 32, so suppose this is my particular number. So here while here 32 is not completely divided 48, so it will enter into the while loop and what it will do, it will do the n mod m. If I will do n mod m, so I will get the answer remainder as what the 16. So my remainder r is what the 16. So after that my n becomes what the m, so my n becomes 32. So my n becomes 32 and my m becomes what the 16, and again I am entering into the while loop, and here I can see that my 16 is going to divide completely 32, so I will not enter into the while loop and I will return the m, and which is written right now is what the 16, which is the greatest common divisor. So in this way we can use the Euclid method, and where here you can see in this particular values of the m and n, it is entered in the while only once. So if we will see that this algorithm with a different example, for example m is equal to 36 and n is equal to 48. So m is going to factorize by using some prime factorization method. So we can write a logic for this. We required one while until it is not equal to 1. So we will divide it and we will do the prime factorization of m. We will find out the factors of m and store in some array, and we will do the prime factorization of n and store into some another array, and here common factor we will find it out and we will multiply it, and the return is going to return as what the 12. In the second algorithm, the first time it will see that whether it is completely divisible. If it is not completely divisible, it will find out the remainder. So remainder is 12. So after that it will enter into the while. My n become 36 and my second number become the remainder. And now my remainder is my second number is completely divisible to this. So that time it will return what the GCD as 12. So now we can understand that one problem can be solved with the many methods. So various algorithms are exist. Now we should have the question that which algorithm is what the better. So obviously we cannot find out the time required to execute the program. Instead of that, what we are doing is we are counting the iterations. So this counting the iteration is useful to find out the whether the algorithm performance is better or not. If it is going to have the more iterations, so the performance is not good. If it is going to require the less iteration, then the performance is what the good. So judging algorithm has the direct relationship to the performance. So The algorithm, all algorithms are best, all algorithms are correct, but we have to select which one is the best. So what we are going to do is, we will measure the, instead of running time, exact running time, we will have the running time as what the operation of the number of the operation needed. So more number of the operation means more running time. Measure the amount of the memory required to run that algorithm, and note that running time of the algorithm increases as the size of the input increases. So whenever we will do the algorithm analysis, we require the two major things: how much space is required or occupied by the program, no, that is what the amount of the memory it required to run to the completion, and second one is, it required how much the time, CPU time or the running time, it is spent by that algorithm to get the output or to solve the problem. Thus, the algorithm can be analyzed on basis of the space and the time. So therefore, in the algorithm analysis, two major things are there, that is the space complexity and the time complexity. The space complexity is referred to the amount of the memory that algorithm needs to run to the completion. So suppose I have the algorithm called as P, and I am evaluating the space required for the algorithm P is C, which is nothing but what the constant. So this is maybe the space which is required for what the code area, or maybe the constant, and plus the SP, which is nothing but what I can say, it is a variable part that consists of the space needed by the component variable whose size is depend on the problem instance. So here my SP is nothing but what the instance characteristic. So we will always concentrate on what the SP. So the next measure is time complexity. So the for the P algorithm, the time complexity is represented by the TP, and it is referred as the time taken by the algorithm P, which is nothing but what the compile time plus what the runtime. But the compile time is what the depend on many factors, what type of the compiler you are using, what kind of the processor you are using. So we will consider this as what the constant, and we will concentrate on what the runtime. But to get the exact formula for the runtime is impossible task, because it is again depends on the architecture. So we will always have to count the number of the instructions or the number of the steps that we are required to complete the task, so that we can obtain the total count for the operation, and this total count for the operation is nothing but what the total count for the program steps. What are the different factors that governing the execution time of the program? So the first one is the architecture of the computer, that is speed of the computer, what type of the compiler you are using, quality of the compiler you are using, and what is the current load on the system right now. So thus it is better we compare the algorithm on their relative time than the exact actual execution time, because actual execution time is depends on many other factors. So we will always concentrate on what the relative time. So we will always find out the total count for the operation, so that we can count only the number of the steps. So the roadmap for this particular point is, we will first describe the input-output relation. We will have the algorithm stepwise instruction which will transfer our input to the output. Then we will have some organized way of storing and retrieving the data, and after that we have to solve the problem by designing the correct and the good algorithm. Framework for the algorithm analysis. So the basic idea is, we have to study the mathematical model of the computer instead of the actual computer. Mentally we have to execute the algorithm on this computer model and evaluate the time instead of the real time. So we will see that what is a mathematical model of the computer. So we will see that the mathematical model of the computer has some RAM model which has some processor and the memory. Memory is a collection of the location, and has the one processor, and it will execute one instruction at a time, and each instruction is going to take the unit time. So if I will execute one addition operation, so I require the one step, one program step. If I will do the some conditional, okay, so that time also I will require the one step. I can have the pointer instruction, I can have the arrow operation, and right now we can see that how many program steps that we required. Here for multiplication we required one program step, for the negative minus, for the subtraction second one, and for the addition the third one. So in this way three steps are required in the RAM model. So same over here for this example, we can see for this assignment we required for the 1, 2 and here this, and the last one is what the assignment we required for the fourth step. So here what we can see that we are going to add the 2 1. So here what is going to happen, we have to find out the total number of the steps. So this one is going to execute n plus 1 time, okay, the for 1 to n and 1 extra for the last time, which is unsuccessful comparison, and this one is going to execute for what the n times the this particular statement. So the total number of the steps are 2n plus what the 1 is nothing but what the total number of the steps is required for this program. So here I can say that here for this particular line I require the one number of the steps. Over here I will require what the this will execute n plus 1, because for last unsuccessful condition it is again 1. So suppose these are the B statements. So this B statement, so it is going to execute n times. So I will say that B statements are there and it will execute n times. So Bn, and for the increment, okay, so here for the increment it will execute again the n time, and this go-to is going to be executed n time. So it is what the 2n. So the total number of the steps are 1 plus n plus 1 plus bn plus 2n. So in this way the total number of the steps that we can write is 2 plus n b plus 3. So the general assumptions that we will do, the maximum time taken by our algorithm A1 to solve any instance of the size is that we have to measure. So there is a goodness of the algorithm and the worst case measure also. So instead of using actual time, we will always have the functional form, which is nothing, which is like linear or the quadratic rule. So the functional form is very much important. So now we can have some analysis of the algorithms. So you can see, you can take this multiplication matrices example and you can find out what is exactly the program steps or program count that is going to required for this particular algorithm. So please solve, students, please solve this particular example. So just take the here. So this is going to be executed 1. So the next is what, n plus 1. Okay. And the next one is what, the n, and what, the n. So total is what the, if you will add all the this frequency count or step counts, you can say 3n plus 2 that I am getting over here. So same over here from L plus 1. So here I will execute this step by n plus 1, and after that this one first time it will execute 1, then the second time it will execute 2 times, okay, next time it will execute 3 times. In this way it will execute up to the L, that is what the n is nothing but what the n plus 1 time. So so what is going to happen, it is nothing but what the n plus 1 divided by what the 2. So the first one is n plus 1 plus the second one is this one, and the third one is also what the n plus 1 divided by 2. So in this way n plus 1 divided by 2 is going to be what the frequency count for the inside statement. So 2 that 2 is going to be cancelled. So here what I can do is 2 plus 1, and here the 2n plus 1 divided by 2, and this is going to be cancelled, and here what I can do is n square plus 2n plus 1 is total my frequency count. So in this way, this is the answer, the total program step or the frequency count for this particular algorithm. So please take this assignment and determine the total program steps or the frequency count for the this examples.